Hello viewers, in today's session we are going to discuss another important and conceptual problem from differentiation related to first principle, right? So here we are going to find out the derivative of secant 4x from first principle, right? So let us start. So now let us first take this function secant of 4x as f of x. So we have f of x is equal to secant of 4x, and from the definition of first principle we know that the derivative of f of x, which is denoted by f prime of x, or if we take y is equal to f of x, then we can write dy over dx is given by this limit, that is limit h tends to 0, f of here we write x plus h minus f of x divided by h, right? So this limit is known as the derivative of y with respect to x, and this statement is known as finding out the derivative using first principle, right? So we'll use or we'll calculate this limit for this function to get the derivative of secant 4x. So now we can write the derivative of secant 4x using this limit, that is limit h tends to 0, and remember here this h is infinitesimally very small, right? So f of x plus h, now f of x is given as secant of 4x, so f of x plus h can be obtained by replacing this x by x plus h. So we have 4 times x plus h, then minus f of x, this is secant of 4x divided by h. Now let us simplify this expression. So we have secant 4x plus 4h, and here we have secant of 4x divided by h, right? Now from trigonometry we know that secant theta is equal to 1 over cosine theta. So using this reciprocal relation, we can now write limit h tends to 0, and secant of 4x plus 4h can be written in terms of cosine function as the cosine of 4x plus 4h, and then we have 1 over cosine of 4x divided by h, right? Okay, now let us simplify this expression by cross multiplication or taking the LCM here. We have cosine 4x minus cosine 4x plus 4h divided by cosine 4x plus 4h, then cosine 4x, and then here we have the quantity h, right? So now we have to evaluate this limit. Now see, in the numerator we have the difference of two cosine functions. So now we can express this numerator, that is the difference of two cosine function, by using this result, that is cos alpha minus cos beta is given by minus 2 sine, we have here alpha plus beta over 2, and then we have sine of alpha minus beta over 2. So this is an important identity from trigonometry, right? So now applying this identity to this function, right? So here we have 4x, which can be taken as alpha, and 4x plus 4h may be taken as beta. So now we can write limit h tends to 0. We have cos alpha minus cos beta, that is equal to minus 2 sine, and then we have alpha plus beta over 2. So alpha is 4x alpha can be taken as 4x, beta is 4x plus 4h. So here we have 4x plus 4h divided by 2, and then we have sine alpha minus beta over 2. So alpha is 4x minus beta, that is 4x minus 4h over 2, and in the denominator we have h cosine 4x plus 4h, and here we have cosine 4x. So now we can write this limit as limit h tends to 0. Here we have minus 2 sine, and see here we have 4x plus 4x is 8x. Then we have 4h divided by 2, and taking 2 common we have 4x plus 2h and divided by 2, so 2 and 2 get cancelled, so we are left with only 4x plus 2h, right? And similarly here 4x and 4x get cancelled, so we are left with the sine of minus 4h over 2, right? So this is 2 times 2 is 4, so we have sine minus 2h, and from trigonometry we know that sine of minus theta is minus sine theta. So here we have minus sine 2h, right? So here we can write minus sine 2h, and in the denominator we have h cos of 4x plus 4h, and here we have cosine of 4x. So now this negative sign and this negative sign, when multiplied together, it becomes positive. So we have limit h tends to 0. We have 2 sine 4x plus 2h, and then we have sine 2h, right? And in the denominator we have h times cosine 4x plus 4h, and here we have cos 4x. Now see, here we have sine 2h, and here we have h. So here what we will do, we'll try to convert this limit into this form, that is limit theta tends to 0, sine theta over theta is equal to 1, right? So what we will do, we'll write limit h tends to 0. So first we have this limit, that is sine 4x plus 2h divided by cosine 4x plus 4h, right? And then we have this factor, that is 2, we can take it outside, and then we have this expression, that is limit h tends to 0 sine 2h divided by h, right? So for converting this limit into this form, here we have 2h, so writing here 2h and multiplying the numerator by 2, this limit is now equal to 1, right? And moreover we have this factor, that is 1 over cosine 4x. So now we have 2, and here our limit h tends to 0, and here we have sine 4x plus 2h over cosine 4x plus 4h. So when h tends to 0, this term becomes 0, and this term also becomes 0. So we are left with sine 4x over cosine 4x, and then the value of this limit due to this result is equal to 1. This is equal to 1, right? So here we have 1, and then we have the factor 2, and here we have 1 over cosine 4x, right? So 2 times 2 is 4, and sine 4x over cosine 4x is tangent of 4x, and 1 over cosine 4x is secant of 4x. So here we have used this result, that is tangent theta is equal to sine theta over cosine theta, right? So the derivative of secant 4x with respect to x is given by 4 times tangent of 4x times secant of 4x. So, viewers, this is how by making use of the concept of first principle, we can arrive at the derivative of given function.